Welcome to Manifested Publishers.
Hello learners, welcome back to our lesson. If you remember in the previous lesson, I left you some questions. I left you 6 questions. These are the questions I had given you in the previous lesson. Therefore, in this lesson, I want to guide you through just a few, and you'll continue with the rest. I want to start with question number 1. And in question number 1, you're supposed to copy and complete the following table. So the table is having the name of the compound, the formula, and the formula mass. And therefore, supposed to start by writing the formula of the compound, hydrochloric acid. The formula of hydrochloric acid, then it is a compound of hydrogen and chlorine. Therefore, the formula should be like that. But again, ensure that the formula is correct by ensuring that the capital letters are written very correctly, and again, the letters are not supposed to be in contact with one another. The formula mass of this one, then hydrogen has a mass of 1, and chlorine has a mass of 35.5. And therefore, the formula mass will be 35.5 plus 1, which is 36.5. That is the formula mass of hydrochloric acid. The second is calcium chloride. The formula of calcium chloride is a compound of calcium and chlorine, then chloride. The valency of calcium is 2. The valency of chlorine is 1, and therefore calcium chloride will be like that. The mass of calcium is 40. The mass of calcium is 40. The mass of chlorine is 35.5. There are 2 atoms of chlorine, and therefore it will be 35.5 times 2, which is 71. 71 plus the mass of calcium, which is 40. This will give you 111. That is 40. The mass of calcium plus 71, the mass of chlorine, which gives you 111. Go to the next, which is sulfuric acid. Then this is the formula of sulfuric acid. That is sulfuric 6 acid. That is supposed to be the formula. Therefore, the mass will be, the mass of hydrogen is 1, and we have 2 atoms of hydrogen. That is now 1 times 2. You get 2. Then you add the mass of sulfur. The mass of sulfur is 32, and therefore 32, or 2 plus 32. And you add the mass of oxygen is 16. 16 times 4, and that gives you 64. And therefore, the formula mass of sulfuric 6 acid will be 2, that is the mass of hydrogen, plus the mass of sulfur 32, plus 64, the mass of oxygen. And this will give you 98. Therefore, the mass of sulfuric 6 acid is 98. We go to the next. The next is ammonium sulfate. This is the formula of ammonium sulfate. The sulfate radical is valency 2. The ammonium radical is valency 1. And therefore, that's why we have dropped the valency at that point. Therefore, the formula of ammonium sulfate, being this one, the relative formula mass will be nitrogen has a mass of 14, then plus hydrogen has a mass of 1, and there are 4 atoms. Therefore, this will be 1 times 4, that is 4. This now you multiply by 2, the 2 which is just inside there. just outside. And you add sulfur has a mass of 32 plus oxygen has a mass of 16, therefore 16 times 4. This is 14 plus 4 is 18. 18 times 2 is 36 plus 32 plus 16 times 4 is 64. Therefore, this gives you 36 plus 32 plus 64. This is 132. 132. Therefore, that is how you get the mass or the relative formula mass of ammonium sulfate. The mass of nitrogen, the mass of hydrogen, then in brackets, you are adding these ones together, and then you multiply by 2. Then you add the mass of sulfur and the mass of oxygen, and you'll get the mass as 132. Lastly, potassium sulfate. This is potassium sulfate. Potassium is an element in group 1 of the periodic table. Therefore, then sulfate radical is valency 2. That is why you are dropping the 2 at that point. This is potassium sulfate. Therefore, the mass of potassium is 39, and there are 2 atoms. Therefore, 39 times 2. Then plus the mass of sulfur, which is 32. Then plus the mass of oxygen, which is 16, and there are 4 atoms. Therefore, 16 times 4. 39 times 2 is 78 plus 32 plus 16 times 4 is 64. Therefore, this will be 78 plus 32 plus 64, which is equal to 174. That is the relative formula mass of potassium sulfate. So you can see how simple these calculations are. Then we just need to sum up the relative atomic masses of all the atoms forming that compound, like we have done. Then again, ensure that you are able to write the correct chemical formulas, bearing in mind the valencies of the various elements and also the radicals. The next question I want us to do is question number 2. Though we have done several such questions when we were discussing about the mole, or how to convert, or how to get the mass and molecular mass, molar mass, and the number of moles. The question number 2 is, how many moles are there in 10.6 grams of sodium carbonate? How many moles are there in 10.6 grams of sodium carbonate? And therefore, we need first to calculate the relative formula mass of sodium carbonate. This is the formula of sodium carbonate. Therefore, the relative formula mass will be, the mass of sodium is 23, and there are 2 atoms. 23 times 2. Then you add the mass of carbon, which is 12, and you add also the mass of oxygen, which is 16. But because there are 3 atoms, then the mass of oxygen in this compound will be 16 times 3. This is 46 plus 12 plus 16 times 3 is 48. This is 46 plus 12. That gives you 58. Then 58 plus 48, that gives you 106. So 106 is now the RFM, the relative formula mass. The relative formula mass of sodium carbonate is 106. then in this case, we are calculating the number of moles. Remember again, when we are doing the relationship between the moles, the mass, and the molar mass, we said that the number of moles are given by the mass you divide by the molar mass. And therefore, number of moles, the mass is 10.6 grams. You divide by the relative formula mass, which is 106. Then this you'll get as 10.6 divided by 106. You get 0.1. 0.1 moles. That is how you're supposed to go about it. So the number of moles of 10.6 grams of sodium carbonate is 0.1 moles. The number of moles of 10.6 grams of sodium carbonate is 10.6 grams. Now I want us to do question number 3, and question number 4 will be question number 4 and 5 as the last ones. Question number 3 is, what is the mass of 0.2 moles of ethanol? What is the mass of 0.2 moles of ethanol? This is the formula of ethanol. Therefore, the relative formula mass of this will be, carbon has a mass of 12. There are 2 atoms of carbon. Therefore, 12 times 2 plus the mass of hydrogen is 1. These are 5, and we have 1. Therefore, the mass of hydrogen is now 1 times 6. We have 5 atoms of hydrogen, and we have another one here. Therefore, the hydrogen atoms are 6, and therefore the mass of hydrogen in this compound will be 1 times 6, because there are 6 atoms. And this you earn the mass of oxygen, which is 16. This will be 24 plus 6 plus 16, which is 24 plus 6 is 30. Then 30 plus 16 is 46. Therefore, 46 is the relative formula mass. The relative formula mass. The relative formula mass of ethanol is 46. In our question, we are calculating the mass. What is the mass of 0.2 moles of ethanol? And you see that the mass is given by number of moles. You multiply by the molar mass. Molar mass and the RFM is just the same. Therefore, the number of moles are 0.2. You multiply by the molar mass, which is 46. Therefore, this will be 0.2 times 46. This will give you 9.2 grams. 9.2 grams. So 9.2 grams is a mass of 0.2 moles of ethanol. 9.2 grams is the mass of 0.2 moles of ethanol. That is how simple these questions are. I want us now to do question number 4. The question number 4 is, how many moles of oxygen atoms are there in 1 mole of copper 2 sulfate? How many moles of oxygen atoms are there in 1 mole of copper 2 sulfate? Therefore, we need first to get the molar mass of copper 2 sulfate. that is copper 2 sulfate. Therefore, the RFM, or the relative formula mass, is the mass of copper is 63.5. You're adding the mass of sulfur, which is 32. You're adding the mass of oxygen, which is 16 times 4 because of the 4 atoms. This is 63.5 plus 32 plus 64. That is 159.5. 159.5 is the RFM, or the relative formula mass of copper sulfate. Our question is, how many moles of oxygen atoms are there in 1 mole of copper 2 sulfate? Therefore, you need to get the mass of oxygen in this compound. And the mass of oxygen is just this part. This is the oxygen we are talking about. It is one of the elements forming the compound copper sulfate. And therefore, the mass of oxygen is just 64. That is 16 this is 16 times 4, which is 64. That is the mass of copper sulfate. And therefore, the moles of oxygen atoms will be 64. You divide by the total, or the RFM of copper sulfate. This is 64. You divide by 159.5. You get 0.4013. 0.4013. The moles, again, the moles you give to at least 4 decimal places if they are many. 0.4013. These are now the number of moles of oxygen in 1 mole of copper sulfate. 0.4013. Give at least 4 decimal places. And the last question is question number 5, which we are going to do, and then I believe number 6 is so simple for you. You can be able to determine the percentage composition by mass of each of the elements in the compounds. Question number 5 is, what percentage by mass of sodium is there in 1 mole of sodium nitrate? So in sodium nitrate, we need first of all to get the relative formula mass. And the RFM, the relative formula mass, is given by the mass of sodium is 23. And you have 1 atom. The mass of nitrogen is 14. And the mass of oxygen is 16. And there are 3 atoms. And therefore, this is 23 plus 14 plus 48. 23 plus 14 plus 48 is giving you 85. So the RFM of sodium carbonate is 85. And we are calculating the percentage by mass of sodium. And therefore, mass of sodium in sodium nitrate, the mass is just 32. Not 32, but 23. Mass is 23. Let's say it's equals to 23. And therefore, to get the percentage of sodium, this will be 23. You divide by 85. 85 is the relative formula mass of sodium nitrate, then you multiply by 100 to make it a percent. Therefore, it's 23 divided by 85 then you multiply by 100. That is 27.06. 27.06%. 27.06%. That is now the percentage or by mass of sodium in 1 mole of sodium nitrate. So that's how these questions are simple. Therefore, I want you now to attempt question number 5 and get some more examples and try and work them out. So that's how simple they are. And that brings us to the end of our lesson today. In the next lesson, we will be learning about empirical and molecular formula. See you in the next lesson.